So this is part 3 of our algebra primer. So it's about polynomials. Polynomials is an algebraic expression that can contain 1, 2, 3 or more variables, x, y, z, and so forth, and have the form of, say, 5 times x squared plus 3, let's say. And we're going to call this a second degree polynomial, second degree polynomial with respect to the variable x. Of course, we can have a more complex form such as, say, 5x squared y squared plus 3. In this particular case, it is not a second degree, but it is a fourth degree polynomial with respect to x and y. Of course, we can have more z and so forth, but we need to pay attention to the highest exponent of each independent variable. Now, as a quick note, an expression that includes rational exponents or even negative. Let me show you an example: 5 times x to the negative 1/2, for instance, plus 3. This is not called a polynomial. Polynomials are restricted when the exponents are integers. In this particular case, we're going to have the generic kind of expression of the algebraic expression altogether. So we can do all sorts of operations between polynomials the same way we do with numbers. So we have operations such as addition, subtraction, multiplication, and division. And now, one important in physics courses, it's more common that you're going to have to add algebraic expressions or polynomials, add and subtract or multiply. And let me give you a quick example where you have, say, two polynomials, x, 6 times x to the 5 minus 10 x to the second plus x minus 45, let's put this in parentheses, and we add this polynomial to another polynomial, which is 13x squared minus 9x plus 4. So the rule of thumb here is that we add apples to apples and oranges to oranges, meaning that we're going to add the polynomial terms that have the same variable, independent variable, x's with x's. And as long as they have, of course, the same exponent. So let's quickly try to find any other exponent in this polynomial form that has power 5. There isn't any, so there is nothing to add to this term. So this remains 6 times x to the 5. Now, what's the next order? It's 2 degree of 2. We got this one and this one, so we get essentially minus 10 plus 13x squared, and that makes plus 3. This is as adding numbers, same exact thing, right? And what else now? We have the next order is x to the power of 1, or just x. You got 1 here, minus 9 here, so you end up with minus 8 x's, and the numbers are just numbers. Negative here, plus here, so we get negative 41, and this is the operation for subtraction, addition and subtraction. In the exact same manner, you can have multiplication, and for instance, 4x squared times, sometimes you will see a dot, sometimes you will not see a dot, x squared inside the parentheses minus x, 6x plus 2, and we're going to use the obviously the distributive laws of this times this. this times that, and this times that, and try to keep a tab on the correct numbers and exponents. So this x squared will yield x4, right? So you got 4x to the power of 4, and then what else? We got this times this, which is 4 times 6 is 24. It's a negative 24, and the exponent is x, and x squared, it's going to be x cubed, x to the power of 3. And what else is left is 4x squared with 2, that's going to yield plus 8x squared. And of course you can see that you can go back and forth between this form and that form just by factoring out. You can factor out 4x, right? If you factor out 4x squared, you're going to end up with this. So these are 100% equivalent. Other kind of multiplication operations that are, we call them algebraic IDs, is of the sort of x plus y squared. The parenthesis is very important because, again, I remind you, this is not equal to x squared plus y squared. Not equal, very important, careful. Essentially, x plus y all raised to the power of 2 is equal to x plus y times x plus y. And again, you're going to do the distributive law and end up with x squared plus 2x times y plus y squared. Now, it would be nice to just remember when you see a polynomial a plus b or x plus y raised to the power of 2 to right off the bat know that this is the result. It is suggested, the more problems you solve, the better it is, to instead of doing the distributive law each time and calculate, you can write directly this expression. There is one more which is very, very important. It's the difference of squares. As you might have heard in your high school years. Let me clean up this part of the board. Erasing is not as easy as it looks. So, for instance, if we have x squared minus y squared, then it's another very important algebraic ID. That is x plus y times x minus y. And of course, you can verify this property by just taking again the distributive x times x, and you're going to find out that you're going to end up with x squared minus y squared. And that is as far as polynomials go, and the next chapter will be essentially the culmination of all that we have said so far, and we're going to be dealing with rational expressions, and that will be the next part.